Today we are going to study linear inequalities. In day-to-day life, we come across situations which we can write as linear inequalities. For example, a man is not taller than 8 feet. If we denote height of a man as x, then we can write this situation as x less than or equal to 8. In another situation, we all know that when we hire an auto, we have to pay some basic minimum fare, say rupees 40. Now the situation is travel charge per kilometer is rupees 10 and a passenger has only rupees 100 with him. Now the question is how much distance he should travel so that the fare will not exceed rupees 100. If the distance he travels is x kilometers, then this situation can be expressed as linear inequality as the basic minimum charge is 40 rupees plus rupees 10 per kilometer into the distance traveled x kilometers, and this amount should be less than or equal to rupees 100 which the passenger has. Obviously, he should travel 6 or less kilometers to restrict his fare to rupees 100. We call them linear inequalities because the power of the variable involved x is 1 in each case, and instead of equal to sign we use inequality signs. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. A similar problem goes like this. Our monthly electricity bill consists of compulsory basic charge rupees 110 and per unit usage charge is rupees 4. To control the monthly bill below 250 rupees, how many units should be consumed? We will start our solution from the question that is asked. Let x units be consumed. So the bill will become basic charge of 110 rupees plus per unit charge of rupees 4 multiplied by the units consumed, and this bill is to be controlled under 250 rupees or 250 rupees. So this is the inequality that we have obtained. We will solve this. We have 4x less than or equal to 250 minus 110, which is 140, and that gives x less than or equal to 140 upon 4, 35. So we have to consume 35 units or less to control the monthly bill at rupees 250. Let us see how to solve 23x less than 100, where number 1, x is a natural number, x is an integer. 23x less than 100 gives us x less than 100 upon 23, which is 4 integer, 8 upon 23. So x will be 1, 2, 3, 4, and this can be shown on a number line 1, 2, 3 and 4. So this is about first question. Now for second question, again we have 23x less than 100. X will be again 4 integer, 8 upon 23, and the solution will consist of all negative integers -3, -2, -1, 0, 1, 2, 3 and 4. So the solution for the second question will be x equals from minus infinity, -2, -1, 0, 1, 2, 3 and 4, which are all less than 4 integer 8 upon 23. Let us see how to solve minus 2x greater than or equal to 9 when x is a real number. Number 2, when x is an integer. And number 3, when x is a natural number. Now minus 2 greater than or equal to 9 gives us x less than or equal to minus 9 upon 2, because dividing by a negative number minus 2 reverses the inequality. So that will be x less than or equal to minus 4 integer 1 upon 2. Now when x is a real number on a number line, the solution will be from negative infinity up to minus 4 integer 1 upon 2. Supposing here somewhere is 0, and the solution can be shown as from minus infinity this minus 4 integer 1 upon 2, and this in the interval notation will be open interval minus infinity to minus 4 integer 1 upon 2 closed interval. Secondly, when x is an integer, the solution will be from minus infinity minus 7, minus 6, minus 5 and minus 4. This will be the solution set. And when x is a natural number, there will be no solution, because in this solution there are negative numbers only, and natural set contains only positive numbers. Let us solve 3 into x minus 2 upon 5 less than or equal to 5 into 2 minus x upon 3. In the first step, by cross multiplication, we get 9 into x minus 2 less than or equal to 25 into 2 minus x. 9x minus 18 less than or equal to 50 minus 25x. 25x plus 9x less than or equal to 50 plus 18, 34x less than or equal to 68, x less than or equal to 68 upon 34, x less than or equal to 2, which is x belongs to open interval negative infinity to closed interval 2, or on a number line from negative infinity up to 2 including 2. To secure A grade, one must obtain an average of 90 marks or more in 5 subjects each of maximum 100 marks. If one scored 84, 87, 95 and 91 in first 4 subjects, what is the maximum mark one scored in the 5th subject to get A grade? Let one gets X marks in the 5th subject. Now the average score will be sum of marks of all subjects, 84 plus 87 plus 95 plus 91 plus this X upon number of subjects 5, and this got to be greater than or equal to 90 to get the A grade. This will be 357 plus x greater than or equal to 90 into 5, 450. X greater than or equal to 450 minus 357, 93. So the minimum marks to be scored would be 93 to obtain the A grade. A plumber can be paid according to following schemes. In the first scheme, he will be paid rupees 500 plus rupees 70 per hour, and in the second scheme, he will be paid rupees 120 per hour. If he works for X hours, then for what value of X does the first scheme gets better? Here, according to first scheme, the plumber gets 500 plus 70x rupees, and in the second scheme he gets 120 rupees. Now, for the first scheme to be better, we should have 500 plus 70x greater than 120x. 500 greater than 120 minus 70, 50x. So x will be less than 500 upon 50, 10 hours. For example, if the plumber works for 9 hours, first scheme will give him 500 plus 70 into 9, 1130 rupees, and second scheme will give him 120 into 9 rupees 1080, where the first scheme proves better than the second scheme. Hence, he must work for less than 10 hours. A and B are working on similar jobs, but their monthly salaries differ by more than 6,000 rupees. If B earns rupees 27,000 per month, then what are the possibilities of A's salary per month? We will start by assuming A's salary to be rupees X. According to first condition and second condition, we have to consider two types of differences between their salaries. The first being x minus 27,000 greater than 6,000, that gives us x greater than 33,000. We name this 1. According to second way of expressing this difference will be 27,000 minus x greater than 6,000, that gives x less than 27,000 minus 6, 21,000. We name this 2. So from 1 and 2 we can write A's salary to be less than 21,000 rupees or greater than 30,000 rupees. The height h reached by the rocket after t seconds from the lift off is given by ht equals minus 5t square plus 100t, where t lies between 0 and 20. At what height the rocket is 495 feet above the ground. Height of rocket above the ground is ht equals 495, that is minus 5t square plus 100t equals 495. 5t square minus 100t plus 495 equals 0. T square minus 20t plus 99 equals 0, which is a quadratic equation in t. Factorizing t minus 11 into t minus 9 is 0. That gives t equals 11 or t equals 9. So after 11 seconds or 9 seconds, the height of rocket above the ground will be 495 feet. Find all pairs of consecutive odd natural numbers, both of which are larger than 10 and their sum is less than 40. Now we assume one odd number to be x. Its consecutive odd natural number will be x plus 2. Now both are larger than 10. X larger than 10, x plus 2 larger than 10, and their sum is less than 40, means x plus 2 less than 40. This means 2x less than 38, x less than 19. Since x is greater than 11, we will start from 11, then 13, 15 and 17, because x is less than 19, and the required pairs of odd natural numbers satisfying these conditions will be 11, 13, 13, 15, 15, 17. These three pairs. A manufacturer has 600 liters of 12% solution of acid. How many liters of 30% acid solution must be added to it so that the acid content in resulting mixture will be more than 15% but less than 15%? 600 liters of 12% of acid means 600 multiplied by 12%, that will be 72 liters of acid. in 600 liters of solution. Now let x liters of 30% solution, that is 0.3x liters solution, is added to 72 liters. So that will be 72 plus 0.3x liters. Now the acid content in the resulting mixture should be between 15% and 18%. So we get two conditions: 600 plus x liters of 30% solution and 15% of this should be greater than this 72 plus 0.3x liters. This will be 90 plus 0.15x greater than or equal to 72 plus 0.3x. This will be 0.15x less than or equal to 18. That gives x less than or equal to 18 upon 0.15, x less than or equal to 120. We name this 1. Now according to second requirement, we write 600 plus x into this 18%, 18 upon 100, that should be less than or equal to this 72 plus 0.3x. This will be 108 plus 0.18x less than or equal to 72 plus 0.3x. That gives 0.12x greater than or equal to 36. X greater than or equal to 36 upon 0.12, x greater than or equal to 300. We name this 2. On a number line, x is between 120 and 300. So the 30% acid solution that must be added to 600 liters will be between 120 to 300 liters. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.